How's it going, everyone? Welcome, Eulier Gonzalez here. I know I have some issues with the lights right now, but well, I just want to focus here by exploring now is the docs of Typescript. My understanding now is particularly the objects, the mutability, and the next topic from the course taught by Matt Pocock about the Typescript classes. So over the past several videos, I talk about or explore the origins of Typescript. And at the end of the day, this was built by a bunch of smartphones at Microsoft when they have an issue for developing applications at scale using this prototype language called JavaScript, where it has this dynamic nature, where it's great for creating rapid prototypes, but when it comes to build now is application at scale, where not only that there is economic incentive on building this, but also some limitation of how large building you can, how large system or programs you can build on your machines, as well as how or what is the ideal size of development and applications. So ideally, you don't want is zero. You don't have any developer, but you have to be realistic. So you started with one, and then from there, depend on the kind of products that you're building and the economic incentive that you have, you might need to hire is another people and create now teams around it. So this is when this becomes more like a social experiment and science, because you need to also define is, well, how much this particularly people can do, and what is the work they can capable of, what is the workload as well, you know. And this is one of the reasons why, for example, TypeScript emerged, and combined with the experience of language like C#, when you can actually see the data flow of your application, right? So this is pretty much the TLDR of TypeScript origins, and then look at how that actually fitting into the entire web development. Traditionally, we just write HTML, CSS, and JavaScript, and now with this additional language, it comes with this particular process, which now we're not writing is interpreted applications, quote quote, but now we are writing is compiled applications. So it has to pass through a verification phase or the build step. And this is how now TypeScript fitting into the entire web developments. And also I look at, well, what are the tools to start using that? So what is the TypeScript compiler? What is the configuration options? And then how you can tweak some of them to give you some nice, some niceties. Like instead of actually having you to reload every time that you change a file from the browser, how you can actually do without it, right? So TypeScript actually comes, or the compiler actually comes with that in mind, like a watch option. And well, how that, for example, is involved in your ID, the integrated developing environment. So those are scenarios, right? When you find yourself building this kind of applications and interacting this, first it's important to dig in what is the current state of the web development, which is using now Vite, which comes with a lot of niceties as well. So hey, you're not only allowed to run as a dev server, but to build your application Okay. Interesting. Very interesting. I'll be right back.
Hola, ¿estás pagando mucho por el abono de...
So, going back here and to make this quick recap about that, and sorry for the interruption, right? Hope you can say, forgive me. And is this how you can start to leverage the different tools, so how you can make sense of all of this, right? That's the TLDR, and that is, hey, in the querying web development you need to have a dev server, and that server must follow is the current state of the JavaScript, the HTML, the CSS, as well as the test environments and the building process, right? That's how you can summarize this. So V actually now help us to do all of that in one place. And then, well, so right now we can is explore more about is how you can look at the essential typings in Typescript by exploring is the docs, and why I always emphasize is to read the docs, mother, and here we are. Okay, so part of the basic here is describing is at least in the docs is this, so static type checking. All right. So most people don't like to get any sort of errors when running their code. Those are considered bugs, and this is one of the reasons why you have things like that. So Typescript is this static type checker, right? Static type system. Describe the shape and behavior of what our values will be when run our programs. A type checker like Typescript use the information and tell us when things might be going off the rail. Pretty basic stuff, right? And I'm going to read this basics, and then describing is the basic typings as well of or everyday types, which is pretty much there's a couple things that is lacking off here, but in any case, so here's the basic, right? Is to well understand this type checking, static type checking, so we can actually get some of this feedback, or when we want to our programs behave the way it is supposed to, we want to run is this static analysis, right? Or static checkings. We also have non-exceptional failures. So far we have discovered certain things like runtime errors, case when JavaScript runtimes tell us that is something is nonsensical. Those cases come up with the ECMAScript specifications. Those cases comes up because the ECMAScript specification has explicit instructions on how the language should behave when it runs into something unexpected. Okay, so for example, if you I'm not gonna click that, but you get the idea. So for example, the specifications say that trying to call something that isn't callable should throw an error. Maybe that sounds like an obvious behavior, but you can imagine that accessing a property that doesn't exist on an object should throw an error too. So instead, JavaScript gives us a different behavior and returns the value undefined. So ultimately, a static type system has to make a call over the code should be flagged as an error in its system. If it is valid in JavaScript, that will immediately throw an error. In Typescript, the following code produces an error about location not being defined, right? So the spec say something of describe is the behaviors of runtimes, and here in Typescript they want us to capture those and throw you and give you a meaningful response, right? So while sometimes that implies a trade-off in what you can express, despite that you can actually in JavaScript have this behavior, all right? But in this case, when the static analysis is running, does not. It has a trade-off in what you can express. The intent is to catch legitimate bugs in our programs, and Typescript catch a lot of legitimate bugs from that. So one of them is typos, on-call functions, right? Operator less cannot be applied to type number and number, right? So it say, hey, this is not exactly operator here, right? So you on-call a function, right? Or basic logic errors. The comparison appears to be unintentional, but the types A and B have no overlap. So in other words, in this case, right? So basic logic errors. So here's the thing. Typescript say, okay, I'm gonna present you this static analysis based on how the spec describe how JavaScript behave, and then I'm going to now capture some of these non-exception failures. All right. So for example, basic behaviors like, well, there is an undefined property in an object you're trying to access, or you are calling, or there's some typos, or there is a function that you are not calling, an uncalled function, or basic logic errors here, especially on the if statement and that kind of stuff. So the other is a types for tooling. All right. TypeScript can catch bug when makes mistakes in our code. That's great, but TypeScript can also prevent us from making those mistakes in the first place. The type checker has information to check things like whether we are accessing the right properties on variables and other properties. Once it has that information, it can also start suggesting which properties you might want to use. That means TypeScript can leverage the editing code too, and the core type checker can provide error message and code completion. It's the type checker that is providing you this. You may wonder how this actually works. Well, because there is a server or an application running locally in your computers that any time that a file change, it goes to now analyze that and also provide you with these suggestions. So in other words, the TypeScript compilers must know what is the shape of this OP that you want to do. This is why we have now types, right? TypeScript takes tooling seriously, and that goes beyond completion and errors as you type. And editors that support TypeScript can deliver quick fixes, and which is something that I already also look at part of this course, right? On the integrated development environment for enhance your superpowers. So this is it, right? So as long as that editor supports TypeScript, it can deliver this quick fix menu to automatically propose some suggestions. So fix errors, refactoring, easily reorganizing code, and useful navigation feature for jumping from to definition to a variable, or finding or referring to a given variable. And this is exactly what this quick fix menu offered to. Hey, you can now fix the errors. You can run some refactorings to easily reorganize your code, or navigate around the features in your codes by jumping to the declaration of a variable, or finding all the reference to a given variable. All of this is built on top of the type checker. and it's fully cross-platform, so it is likely that your favorite editor has TypeScript support available. And then you have now the TypeScript compiler here. Okay, so we have been talking about type checking, but we haven't yet used our type checker. And let's acquaint with our new friends with this. So this is the type checker at the end of the day. They call this TSC, the TypeScript compiler, but at the end of the day is a applications that run static analysis on TypeScript files, and if there is an error, they're gonna provide the hints, right? I'll be right back. All right, keep going. And then you have the TypeScript compiler here, okay? Types for tooling, the TypeScript compiler, to install the TypeScript compiler TSC. You can use npmx or similar tool if you prefer to run TSC from local modules. And let's move on to an empty folder and try writing your first TypeScript programs. Hello this. So this is how it's going to tell the compiler to compile that, right? What exactly? We run TSC and nothing happens, right? So it's because, well, you actually write a valid JavaScript file, right? And there you go, right? So this is the TypeScript compiler here, emitting with errors, okay? So you can say things like, one thing you might not have noticed from the last example was that our hello.js file changed again. If we open that file up, then we'll see that the content still basically looks the same as our input file. That might be surprising given the fact that TypeScript compiler report an error about our code. But this is based on one of the TypeScript core values. Much of the time, you will know better than TypeScript. To reiterate from early type checking code limits on sort of programs you can run, and so there is a trade-off of what sort of things a type checker find acceptable. Most of the time that's okay, but there are scenarios where those checks get in the way. For example, imagine yourself migrating JavaScript code over TypeScript and introducing type checking errors. Eventually, you will get around to clean up things for the type checkers. But that's the original JavaScript code was already working. Why should converting it over to TypeScript stop you from running it? So TypeScript doesn't get in your way, and of course, and over time, you may want to be a bit more defensive against mistakes, and make TypeScript act a bit more strictly. So you say no emit errors is a way to tell the compiler, hey, let's go to skip this for this moment while I'm migrating here. Emitting with errors or not. Then you have now explicit types, all right? What we did was to add the type annotations and basic typings annotations, all right? So whether it's a primitive or more complex, like the arrays or objects, right? Argument of type string is not assignable to a parameter of type date, right? Perhaps surprisingly, calling date in JavaScript returning a string. On the other hand, constructing a date with new date actually gave us what we are expecting here, right? So that's what we need to generate is now a date. Keep in mind, we don't always have to write explicit type annotations. In many cases, TypeScript can just infer or figuring out that. And then erase type. Okay, so let's take a look at what happened when we compile the above function greet with TypeScript output JavaScript. So you get this, right? You say, hey, use a strict, and then it tells the engine to opt into this mode. So running some static analysis in JavaScript, as well as the use of hosting, right? So function greets, you get this person and date, console logs, And there you go. Notice two things here. Our person and date parameters no longer have type notations. And our template string here that used the backticks was converted to a plain string with concatenations. More on that second point later, but let's focus on the first point. The type annotation aren't part of the JavaScript or ECMAScript to be pedantic. So there's really aren't any browser or runtime that can just run TypeScript unmodified. That's why TypeScript need a compilers in the first place. It needs some way to strip out the transform any TypeScript specific code so that you can run it. Most TypeScript specific code gets erased away. And likewise, here's our type annotations were completely erased. Remember, type annotations never change the runtime behavior of your program. This is part of the thing that reading about the basics, bro, and down leveling. And one another different from the above was that our template string was reading from this. Hello person, today is the day this, to the hello.concat the value that you have in person with this another string, and then concat the date to string with this another string. Why did this happen? Template strings are a feature from a version of ECMAScript. Exactly. TypeScript has the ability to rewrite code from newer versions of ECMAScript to older ones such as ECMAScript 3 or 5. This process of moving from a newer or higher versions of ECMAScript down to an older or lower one is sometimes called down leveling. For the TypeScript output, by default, TypeScript target ES5, an extremely old version of ECMAScript, and we could have chosen something a little bit more recent by using the target option. Running with this, change TypeScript to ECMAScript 2015, meaning code should be able to run whatever ECMAScript 2015 is supported. So running TypeScript compiler target is this, and now analyze and generate the JavaScript code. The following output is something like this. While the default target is ES5, the great majority of browsers support ES 2015. Most developers can therefore safely specify ES 2015 or above as a target, unless compatibility with certain ancient browser is important. The other is a strictness. Different users come to TypeScript looking for different things. In a type checker, some people are looking for a more loops up in experience with what can help validate only some part of their program and still have a decent tooling. This is the default experience with TypeScript, where types are optional. Inference takes most of the lenient types, and there is no checking for potential null or undefined values. Much like how the TypeScript compilers emit in the face of errors, these defaults are put in place to stay out of your way. If you're migrating existing JavaScript, that might be a desirable first step. In contrast, a lot of users prefer to have TypeScript validate as much as it can straight away. And that's why the language provides strictness setting as well. This is strictness setting turns static type checking from a switch, either your code is checked or not, into something closer to a dial. Into a dial. A dial. The meaning? Meaning dial. Do you have an image like a dial? Okay, a dial. To measure with or as if with a dial. With a dial. But what is the dial? to operate a phone call to someone by choosing a particular series of numbers. Oh, to a dial. Okay. So to measure, to a dial. Okay, to a device to measure the things. To a dial. To a dial. Okay, una perilla. Similar to a dial. Okay. Closer to a dial. Okay. So the further you turn this dial up, the more Typescript will check for you. This can require a little extra work, but generally speaking, it pays for itself in the long run and enables more thorough checks and more accurate tooling. When possible, a new code base should always turn this strictness check on. Typescript has several type checking strictness flags that can be turned on and off, and all of our examples will be reading with all of them enabled unless otherwise stated. The strict flag in the CLI or strict true is coming from the configuration. Toggles them all in simultaneously, but you can opt out of them individually. The two biggest ones you should know about are no implicit any and strict null checks. Interesting. So again, because this is part of the basics. So some developers want to opt into gradually, all right, as they're starting to use Typescript to have a decent tooling, all right. But sometimes there are others that prefer go straight away with it, right? And for those cases, so we have now we have like a switch, right, of this static type checking or the strictness of the static analysis. So this pretty much like a dial when you go from one place to another, okay, and you can choose, you can tune in there. And the two more important, or the two biggest one, the two biggest dials are no implicit any and a strict null check. No implicit any recalls that it's someplace Typescript doesn't try to infer type for us, and instead fallbacks to the most lenient type, any. Isn't the worst thing that can happen. After all, falling back to any is just a plain JavaScript experience anyway. However, using any often defeats the purpose of using Typescript in the first place. The more type your program is, the more validation and tooling you will get, meaning you will run into fewer bugs in your code. Turning on the implicit any flag will issue an error on any valid variables whose type is implicitly inferring as any. Okay, that's right. So if you define any, you have now an error. So the Typescript will comply, will yell at you. And the other is a strict null check. By default, values like null and undefined are assignable to any other type. This can make writing some code easier, but forgetting to handle null and undefined in the case of countless bugs in the world. Some consider it a $1 billion mistake, which is the null reference. That was in 2009.
Well, thank you all very much. Thank you. Very nice to see so many of you here again. It wasn't me that decided to give 2 talks at this.
Tony Hoare. Typescript handbook, direct me here. Me too. Oh, for real? yeah, that the basics. Throw me here. The basics throw me to the origin. Okay, so the $1 mistake. Got it. So Tony Hoare, right? And this him. Okay. British computer science. Holy moly. Okay. Okay. Who made foundational contribution to programming language, algorithm, operating system, formal verification, and concurrent computing. That's a lot. Oh, rest in peace, bro. Rest in peace. 5 March 2026. Age 92. Rest in peace, my friend. Absolute. In 1916, Hoare left the Soviet Union and began working at Elliott Brothers LLT. Damn, son. Okay, anyway. He went through Moscow State University as a British Council exchange, where he studied machine translation supervised by Andrei Kolmogorov, a Soviet mathematician here. Holy moly. Yeah, go in peace, my friends. Okay, interesting. Oh my god. As well as the Microsoft research in Cambridge. Formulated the leading philosopher problems. Hoare developed a sorting algorithm, Quicksort. He developed the Hoare logic, an axiomatic base for verifying program correctness. It's a formal system with a set of logical rules for reasoning rigorously about the correctness of computer programs. Okay. Interesting. But again, that goes beyond of today's video, right? It's like getting a quick rabbit hole. But it's this, right? Some consider it a $1 billion mistake. The strict null check flags makes handling null and undefined more explicitly, and spare us from worrying about whether we forgot to handle null and undefined. The strict null check is false. Null and undefined are effectively ignored by the language. This can lead to unexpected error at runtime. When set to true, nulls and undefined have their own distinct type, and you will get a type error if you try to use them where a concrete value is expected. So for example, with this TypeScript code, user.find, right, has no guarantee that it will actually find a user.find, despite that the user is now a collection that of course has that particular methods find a user, but you can write code as though it will. Setting struct null to checks to true will raise an error that you have not made a guarantee that the login user exists before trying to use it. Login user is possibly undefined. The second example failed because the arrayFind functions looks a bit like this simplification. It say, hey, this is the predicate, right? And the thing here is that I don't know what is the shape of this. Value any index numbers of the boolean, which can be s, which can be that value, or it can be undefined. When strict null check false, the undefined is removed from the type system, allowing you to write code which assume it always found a result. So it actually detect for this null and undefined errors. So this is pretty much it, right? Reading the basic of the spec. So that'll be all for this video. Take care. Bye bye.